So what we're doing next, obviously before we left, we had finished marking up our P&IDs for our units and identifying potential waste streams. So now what we're going to do is, Laura, is that on?
Yep.
Okay. Now what we're going to do is go through, and for each of the potential waste streams that we identified, we're going to document those in a spreadsheet, which is what we call our documentation and compliance tool. So each little group has a computer there in front of you, and you should have a blank spreadsheet there. I'm going to have to pull this over to the side like she did earlier. I think I've figured this out now, so we'll see if I can do it without her help. And okay, that should be fun. Okay, so in the spreadsheet, you can kind of play with it. You'll see that some of the cells have formulas, and those are the ones that we've built in to kind of say, to look through all the information that we're entering and say, hey, is this going to be included as a tabs, waste stream or not? And the same for 6BQ. So we start with, for our documentation for each waste stream, we document what process unit it came from. Most places process units have numbers, so we put the process unit number, process unit name. Then the P&ID of where the vessel is, where we have this waste stream exiting, P&ID number, and typically there'll be a date as well, but we don't have that on here. The vessel ID that we're looking at, and then the name of that vessel. And here, we're putting whether or not, okay, so that's not one that's pre-populated. Normally here, sometimes it's a drop down, sometimes you're just typing it in. You're putting whether or not it's a process vessel, PV, or a waste management unit, WMU. So moving on, then you're going to describe the stream. So crude column overhead water boot to process sewer. That's the kind of thing that would go right here. And then you're going to classify it. Let's see if this is a drop down or if, okay, so that's not a drop down. Oh, thank you very much. There we go. So then you're going to classify it as a point of generation, is it sour water, double count, in-process recycle, excluded waste. We have some other ones on here, so like vacuum truck. So you might have something, it doesn't get drained somewhere, but you have a vacuum truck that comes and picks it up. You might want to document that there as well, so you know that you need to look at vacuum truck logs. Here's where you mark whether or not it's a process. You just put an X if it's a process wastewater, tank water draw, landfill leachate, or other. And then you have your destination equipment. So, and keeping in mind that the destination equipment may not be on the same page that you're on. So say it was going to the benzene stripper, so that desalter effluent stream going to the benzene stripper, you put the stripper identification number here, benzene stripper name here, and of course that is a waste management unit. So now I'll look at the right place here. Waste management unit, process vessel, or other. So a benzene stripper here in this case would be a waste management unit. And then the P&ID that stripper is actually on. At this point, we're not going to go past that. We're just going to stop there at actually labeling the source and the destination. So we'll do the first couple together. Of course, I don't have the marked up ones in front of me. All right, so on that first page, sheet 1 of 14, where we had our reflux coalescer. We're going to go over here. Let's see, our process unit, it says down at the bottom, our unit, process unit is number 1. process unit name. This is our crude unit. The P&ID number, for us, ours are easy in this exercise. This is just P&ID number 1. So we're looking to identify all the waste streams that we found on the page. So I'm going to start, and so there could be, from that reflux coalescer, three line items probably here. We have the 1-V-20. That's V, not C, sorry. Reflux coalescer. And this is a process vessel. Okay, our stream description, so I'm just going to pick one of the two. So reflux coalescer to oily water sewer. And this is, what did we say this was? It was pink, so it was a POG, right? I'm going to say this is a process wastewater, because that's a category it seems to fit under. All right, so the destination equipment. Well, oily water sewer doesn't typically have an equipment number. So you can put OWS for oily water sewer. And oily water sewers are part of the individual drain system, which is your WMU type. And that P&ID, so a lot of times you don't have to put the P&ID for the process sewer because it's not, the sewer itself isn't necessarily always reflected on P&ID. Or what you could do is just put the P&ID where you show that stream actually going to that hub or sewer. So you would put this one there, or you could just put NA. Sometimes you'll have a stream leaving a vessel, and it'll go 2 or 3 pages in a line before it dumps to an oily water sewer, and that's why sometimes it's beneficial to go ahead and actually put the page, the P&ID number of the page where you actually saw it on a drawing going into the sewer. So I'm going to put 1. And again, so for this one, I'm just going to copy this because I have 3 more streams. That are going to be the exact same thing except for where it's going. So that other stream to the sewer is off of the water boot. So it's coming off of the same vessel, right? So all of that stays the same. But to be able to decipher what I'm talking about for description, I'm going to put reflux coalescer water boot to oily water sewer. That is also a POG. That is also a processed wastewater, and it's going to the same place. So for these lines, for the cells are just manual entries. A copy paste is typically okay, but you have to, depending on how your spreadsheet is set up, if you have calculations, built in, you'll need to make sure that you're not copying something incorrectly down. And then finally, for the last stream from that vessel, I have reflux coalescer water boot 2 instead of the oily water sewer. It's going to the, where did we say that was going? To the sour water stripper system? Or I'll just put sour water stripper. And so how would we classify this stream? So it's not a POG, it is SWS. So the way we have these, the way we have our tab column set up is we look over here, and if that doesn't say POG, it's not summing up to your tab number. At the top, all that sums up. Like if tab equals X, then it would add up there. And over here, This isn't one where we have a P&ID where it shows it directly going to, it just says the box 98. So I'm just going to put, typically what we like to do is even if it's a sour water system, we're going to try to find that next vessel, that next waste management unit that it is going to. So the other things that you could put on this page, like we talked about, were like level gauges. So if you chose to list every single level gauge on this spreadsheet, you could. I think that's probably, I mean, typically these databases are already pretty large anyway, several hundred, rows potentially, maybe more, maybe it's into the thousands. But how I like to do it is I like to list level gauges on a separate tab and bring them in refinery-wide level gauges under one line item. So I typically don't go and list all these level gauges that may drain to the sewer on this page. Again, it's up to you, however you may want to do this if you were to go through this exercise. So you guys flip through your P&IDs and kind of just practice picking out your points of generation, your double counts, things like that, and enter them into the spreadsheet. So you don't have to do all of them. We don't expect you to go through the whole book, but this is just kind of giving you an exercise of documenting your waste streams. does it say tab?
What's the contribution? Because this is calculation you have to have.
Oh.
So I was going to have these three together. Because that's for the water.
15,000 ppm
And divided by 100.
for the water phase
Yes, this is for the water.
times, what's the quantity?
The 19.
Where did the 19 come from?
5,000 gallons. And then I used 1 gallon of water. I used 3.8 kilograms. And then I converted it to megagrams.
And so that's water phase contribution. So you did that up there. Did you forget your 3.8? Oh no, you got your 3.8. How many, and that's for 1 month? How many months are in a year?
That's for 1
There we go. What you got? Still working. It's okay.
If the water drops, so this is also monthly.
Right. 26, 22. You got some decimal places.
468.
Oh, there we go.
Close.
But those are the right numbers, but you've got some decimal place things going on. Like the actual digits are right,
Yeah.
because that should actually be 0.126, and that should be 0.0342.
Okay. So it comes out to that.
No, because your decimals are wrong. Because like the 1 would come down,
Oh.
and the 2 would add with the 3. Yeah. So I'd have to, yeah. I don't know where your conversions went wrong, but it's probably it's with the whole. So that's 1,000. Oh, is that kilograms or is that
Yeah.
megagrams? Oh, so that's 0.12, but that's kilograms too.
Yeah.
Because that should be 0.0342. So there was a. So this one is off by a decimal place. That one is right if that's kilograms, and that one's off by a decimal place. Geez, other numbers. Sorry. Oh, that's 0.126. What did you do? Did you put in too many zeros? All right. Everyone ready? Kind of ready? You want me to give you another couple minutes if you're close?
Go ahead.
All right. So basically, she's going to pass. She'll pass out. Go ahead and pass out the answer sheet to you, so you can kind of follow along. So you've got for the water phase again. So your concentration for your water phase was going to be 150 ppm, which you got by dividing by 100 of the gasoline concentration. So you've got 5,000 gallons per month times 12 months per year. You have to do the conversion from kilograms to gallons. 150 ppm, so that's 150 divided by a million. And then your conversion from megagrams to kilograms, or kilograms to megagrams, sorry. So water phase, you should have gotten 0.0342. Organic phase, the same thing there, except you're using a different conversion factor, and your quantity is 5% of the 5,000, right? And you're using the 15,000 ppm. And you come up to 0.126 and add the two together, and you should have gotten 0.16 for the tab. And what's the contribution for the 6BQ or 2BQ? Is it any different? No, because the whole stream is going to the uncontrolled sewer. Okay, so we have another one. Here, with what's being passed out, we have a water wash column overhead. For this one, we have 5 gallons per day removed from the water boot. And we have 5% hydrocarbon carry-under. For this one, that 5% is 5% of the 5 gallons. So it's a total of 5 gallons that's drained, and 5% of that 5 gallons is hydrocarbon. The flow-weighted annual average sulfur concentration is 11.5. Flow-weighted annual average benzene concentration is 1,000 ppm. Use your conversion factor. What is your contribution to the tab from this? You're already taking too long. It's hard pipe to the sour water stripper. So yes, you are exempt from reporting this on your tab. And for TBQ, 6BQ, well, that's not actually on this page. It doesn't come from here. It comes from the effluent of your sour water stripper. Why is that so loud? Hopefully you can't hear it downstairs, only when it's loud. Okay, one more. One more. We have a groundwater recovery system. So pay close attention to the multiples and frequencies here. So 4 recovery wells are pumped at 1 gallon per minute each for 50 hours per week through hard pipe to a recovery tank. We see our recovery tank here is open top, so it's not controlled. The recovered groundwater includes 1% gasoline. So that 1 gallon per minute, 1% of that 1 gallon per minute is gasoline. We have a weathered gasoline benzene concentration of 10,000 ppm. We have our conversion factors for our water and our gasoline. Open top recovery tank. And the tank is pumped out by a vacuum truck every week. But the vacuum truck offloads at a hard pipe connection to a B1 compliant slop tank. What is our tab contribution? And what is our contribution to the BQs? So we gotta have remediation, so that is exempt from, so we're exempt from our tab reporting. So, however, we are uncontrolled, so that brings the quantities into our BQs, right? Oh, and they can still hear me downstairs.
Who's listening?
It's a QQQ class. Oh, well, thank you. Who's listening to me? Hopefully you guys are.
I'm confused about what's going on with this camera and stuff.
Isn't that Dave guy from ERM teaching the class?
QQQ?
Yeah.
No, that's us, Emily.
Oh, I thought I heard he was teaching it.
No.
I just imagined him.
No, it's Emily Barron from our Detroit office. Everyone, it's not like the whole thing, but, I mean, she's down there teaching, and she has one of these too. And she said when she's standing up front in a certain location, I don't know if their mic's on or off or what, but they can hear me coming through their speakers instead of her. Isn't that awesome? I'm glad it's Emily and Laura at least. They told, a couple of the clients came up and said, yeah, we can still hear you. Hi, guys. I know. Okay, so we were going to go over the answers. Do you have the answer sheet for these for a waste management unit exercise? All right, so we were looking at our schematic. Oh yeah, that's gonna kill the sound on the microphone. Let me take all of this off. It does feel louder. I think what it is, this jacket's a little more flimsy than the one, and it keeps folding up underneath. But you could hear me, because I'm plenty loud, right? Okay. This is true. Okay, so 1V1 is our benzene stripper. And what kind of a waste management unit type is that? It's a treatment process. So for 2BQ, you would treat it as that. For 6BQ, you'd likely just call it another waste management unit. It's a fixed roof tank is what it looks most like. And those require what type of inspection and monitoring? Quarterly visual and annual NDE. Right, so both of those. Yeah, look at this. All right, and our 14 tank 102, that's our slop tank. What would those likely fall under? Is it a floating roof, if you're looking at the bottom for the, so it's a floating roof tank. So more than likely those you'll fall back on KB for. Same for the transmix tank. Up at the top it is also a floating roof tank. You would fall back on KB. Our vacuum truck unloading sump. So you have controlled vacuum trucks there in the center. 18-S-3. What type of waste management unit is that? It could be part of an individual drain system. So it really depends. For these sumps, sometimes it really depends on what it looks like. So a lot of these sumps would just be part of the IDS and quarterly visual. Some sumps are actually kind of tanks, that are inside, say, a box. And if it's vented to a closed vent system, you would need to ensure that you're capturing the lid in the closed vent system, like Mary Claire was saying, which would be the no detectable emissions. So if you're looking at it as part of an IDS, then it's just quarterly visual. Your drains down at the bottom to the junction box, right? They're part of the IDS, so they require what type of inspection and monitoring? Just quarterly visual. The junction box the same, part of the IDS, right? So just quarterly visual. Above ground sewer lines, so that's any of your controlled above ground sewer lines, also part of your IDS as a quarterly visual. Your NPT and CCR sump itself. So this is one, so it's called the sump, but it looks a lot like a tank, and it also looks a lot like an oil water separator, right? So some would look at that and call it an oil water separator, which would require what type of monitoring? The NDE and the quarterly visuals, so both. Then you have your API separator. That's vented to atmosphere, so is there any inspection monitoring requirement for that? No, because it's not controlled. Spent caustic tank, tank 220, down the bottom, toward the bottom of the page. Does that require any inspection monitoring? No, because it's uncontrolled as well. Your lab tank, back up to the center. So that's a fixed roof tank. That would require quarterly visual and NDE, annual NDE inspections. Let's see, you've got 2 DAFs, so if we're looking at V9, that one is controlled. And DAFs are oil water separators here, right? So that requires both the quarterly visual and the annual NDE. Your other DAF, V10, is not controlled, so there's none there. Activated sludge unit, you do not do inspection monitoring there. But what do you have to worry about for an activated sludge unit? The inlet concentration. So that's your clarifier tank is also typically an open top tank, so you would not do any there. How about vacuum trucks? So you have both controlled and uncontrolled vacuum trucks. Actually, it shows them all controlled. So what monitoring would you have to do under your vacuum truck? What type of waste management unit is it? How do you classify them? It is, yes, you would classify those as a container, which require both quarterly visual and annual NDE.
To clarify, what type of WU is?
It's open to the atmosphere. It's not controlled. So those are those big open top systems that have the rakes that kind of move, so you don't have to monitor those. What's that? Where? At any potential leak interface? So they all have, you're looking at the actual container itself.
Yeah, schematic that
'Cause-
shows
So,
all the parts that could
all the-
leak.
right.
And we go monitor all the seals. And it's a typical. There's usually about 3 or 4 different styles out there. So we got 3 different diagrams, and we choose the best style and add to or take away if we have to.
right.
But it's tons of little places
Right.
on there.
And so the interesting point, so you're in Texas, so you know MSS, right? Or you're familiar with, I'm not sure if you've dealt with it or not. But under BWON, you don't have to do anything with the vent on the vacuum truck to consider it controlled. All you have to do is quarterly visuals and annual NDEs. Obviously, when you do those, you need to make sure there's liquid in there, because, monitoring an empty vacuum truck may not be the best indication of whether or not you're leaking. But for MSS, for those that are in Texas, pretty soon many other states will be falling in, you actually have to control the vent off of a vacuum truck if you are using it for maintenance activities and it's greater than 10,000 ppm, or no, it's the vapor pressure, greater than 0.5 psi vapor pressure.
With the carbon cans or something.
Right.
That's only in Texas.
At this point, it's only in Texas, I believe. I don't think the MSS regulations have, because each state is, creating their own based on the SIP.
I mean, some people do it for best practice out a lot.
Right.
Refineries, but
We do it that way.
yeah.
I think hydrocon has controlled factors.
Right. So a lot of them had to go retrofit. Some of them are actually, some of them are doing carbon, a trailer with carbon canister or something like that on the back. Is it Hydrocon that actually routed their vent stream through the actual internal combustion, their engine? One company did that in order to control. I can't remember which one it was though. All right. So what if your facility typically classifies flare knockout drums as process vessels? Because that's what they are, right? Flare knockout drums were required way before the B1 rule came into play, and they're there for safety, to prevent liquids from going to the flare. 1 year, your facility turnaround manager tells you that he wants to pump wastewater to the flare knockout after de-inventorying and steaming out vessels upstream. So there's a difference. A flare knockout pot is to knock out trained water in the vapor strings that are venting to the flare. As a safety device process vessel, it's not designed, or typically supposed to be designed, to receive liquid wastes. So if you start doing activities like this, you think it would change how you classify your flare knockout drum? If you start pumping wastewater to it or de-inventorying liquid waste to it? Yes. And what other considerations would have to be made if you bring your flare knockout drum into the B1 program as a waste management unit? Again, you've brought in your refinery flare probably to your B1 program as a control device, which brings in a lot of extra piping for inspection and monitoring. So,
I'm so confused by that. You're bringing the flare. Why are you monitoring everything on the flare?
if you, well, it really, on your flare lines, on your vapor lines, I mean, those are not in a lot of, depending on what the flare is. I mean, a lot of people have different facility flares. But between the flare knockout pot and the flare itself, do all of your facilities have that line in for method 21 monitoring?
I would say it's greater than 60%.
So maybe not everybody.
And if not, they're doing quarterly, they're doing an annual visual.
An annual visual, but
Yeah,
not an
no.
annual method 21.
No, but I
Right.
would say it's more than not.
So yeah, so not all facilities have.
Because that's really, I mean, as far as what you're tracking for the pilot outage and
All right.
that heating value.
Yeah, all that, because you're falling back on what JA, which is what you have to follow anyway for a flare, whether it's a B1 control device or not. It's more about the closed vent system piping, because all of the flare piping now in the plant now becomes part of your closed vent system. And a closed vent system requires quarterly visual and annual method 21 monitoring. So you could make the case that, hey, this is only a turnaround only, and maybe only during that period am I going to use this as a waste management unit. So you're not bringing it in full-fledged throughout the year. But if you are using, but some people actually are using their flare knockout drums for this purpose on a regular basis for routine maintenance, not just turnaround. So those have probably bigger issues with bringing that in. So you change that to WMU, you have to make sure all the lines leading to the flare knockout drum are captured. And then all above ground sewer lines, and then your vent lines. So like I was saying, your vent lines. Of course, the lines leading it into it, those are only quarterly visuals. But it's your annual, it's really the NDE on the flare piping that gets it. But it's also a lot of piping. There's a lot of flare piping that goes throughout the facility, probably a lot more flare piping than there is sour water piping. All right, so if your facility has a set of carbon canisters on a particularly nasty sump that indicate breakthrough almost every time you monitor them, what does it mean to your tab or BQ, if anything? Does it mean anything? No, probably shouldn't. What about overall B1 compliance? Right. More than likely, for some reason or other, maybe your carbon system is no longer designed properly. And have you increased your monitoring to 20% of design breakthrough? So if your design needs to change, so if you're breaking through every time, that means more than likely you need to increase frequency, right, of monitoring.
Well, if you're doing it daily, you would
you're doing it daily, I would really look upstream and figure out who's dumping what to the system that doesn't need to be there, or you just need to increase. I mean, if that's your new normal, you need to resize your carbon canisters. So, what's that? Or give Vapor Point a call. But it's on tape. So, one thing you might want to look upstream and just ensure that there's something that may be going to the process sewer that shouldn't be. But I don't think it should ever, you shouldn't consider it uncontrolled. More volumetric flow, you need to redo your carbon design, change your monitoring interval, all of those things like you had said. Okay, so what if you have a set of carbon canisters that used to break through all the time, but all of a sudden they stop breaking through? What does this mean? What do you think it means?
Doing something good.
Hmm?
Doing something right.
Something very wrong. Like, what if there's a leak somewhere?
More than likely, there's a sump that there's a big hatch wide open. There's a bunch of drains that have no water seals. It's following the path of least resistance, which is not through these carbon canisters. It's venting somewhere else upstream, which is supposed to be controlled. That is the likely scenario. So you want to verify that maybe the process did change. Maybe they took the high VOC stream out of the sewer that used to go there. But need to also check and make sure that everything upstream is vapor tight like it's supposed to be. Yay, I get to quit talking.
Okay. So now we're going to talk just, I don't like this. Okay. So now we're going to talk just a little bit about the rule history and background and how we got from way back in the late 80s to today and just the development of BWON. So BWON started a while back. It was initially proposed in 1989, and there was a lot of arguing between the agency, between industry. API came in, wanted to file for reconsideration. Conoco and Sun with Exxon filed lawsuits against BWON. API settled. And then EPA proposed, the proposed rule stay was in December of 1991. And then it was stayed and amendments were proposed in March of 1992. So then the stay was lifted on January 7th, 1993. So this is when the rule came into action and you had 90 days to file your first tab report. So that is where the April 7th deadline comes from. And then, so that was in the early 90s. And then people still had a lot of confusion, a lot of questions. The BWON rule it's pretty poorly written. It's very hard to interpret. And so EPA came out with an FAQ document, which is on your flash drives. It breaks down common questions, answers, EPA's responses. And then, so that was in 97, and people took the document. They were able to address some things in their facility, but there were clearly a lot of things that were wrong. So EPA decided to take the route of enforcement. They got DOJ involved, and we come out with our consent decrees. So Koch Industries got the first refinery consent decree in 2000. And within these initial consent decrees, they all had your pretty standard, you'll trigger J on your CAT, you'll do LDAR B1, kind of brought in all of those with NSPS and then threw in the NESHAP with B1. So that was a key part in the consent decrees. And then in 2007, Equistar comes along and gets the first chemical plant consent decree,
By the way, that one's closed.
which, yes, closed.
Closed.
Right, and I don't think any refineries have.
Possible.
Yes.
That is, I think that may be the only reason.
Yeah, we have, I have a client I'm working with who they're in the final negotiations with EPA, but they haven't really heard back from them yet. So hopefully within the next year or two, we might kind of start hearing of a refinery actually closing their consent decree. And then 2007, we get some more clarifications. And then just future rulemaking. A lot of times something in B1, it'll stay quiet for a while, and then EPA will do their NEIC audits, their consent decree audits, and something might pop up. And that could be,
I will say for that future rulemaking,
Yeah.
Ken Gehring is slated to, there's a fireside chat with Ken Gehring. He is going to talk a little bit tomorrow about some of the things with the future rulemaking that may or may not affect B1 or Q. And I believe that David Friedman is giving a talk, I don't know if that's tomorrow or Thursday, on the refinery, the new refinery sector
okay.
as well. So a little bit of what Ken was talking about is about the same, it's about the same as some of the stuff that David will be talking about.
So some B1 resources, all of these are on your little flash drives. We have the preamble to the proposed rule, which has a lot of just general information. We'll have our health risk on benzene, proposes and evaluates control requirements. And this is where we introduce the 1 megagram per year control option. And then we have the preamble to the final rule in 1990, and it addresses all the comments to the proposed rule, and it introduces a lot of the terms that are very key and important to B1, with the point of waste generation, dilution is not the solution kind of thing, EBU, and other special treatment options are all introduced within this preamble to the final rule. Here's some other resources from all of these where it was promulgated, stay was lifted. You can see that B1 has been a very confusing rule, and people have had a hard time understanding it with all of the back and forth on the rule.
Every single one of these documents, they're all, some are really lengthy, they're all on your.
Yeah. If you're ever bored one night and can't sleep, read your B1 stuff. The proposed rule final stay in December of 91. It announced to stay on the final rule compliance due to widespread confusion. This is with all the lawsuits, Exxon, Conoco, Sun. And then the preamble of the final stay in March of 92, it talks about several important concepts, helps define some things like what is an organic waste, exempt waste. This is where you hear about remediation, your sour water streams, maintenance and turnaround waste, and then waste received from off-site. And the final rule, within the final rule, it responds to all of the comments on the final stay and clarifies a couple things. Turnaround, points of generation, go more into sour water, the different types of streams within process, remediation waste, controls, water seals, and then this is where we get the 6BQ and 2BQ compliance options. Okay. The preamble, the direct final rule, this is where we get an exemption of fuel gas, any type of vapor, from B1. Clarifies the control requirements for tanks. And then 2003, preamble, partial withdrawal, direct final rule, and then preamble to a final rule on December 4th, 2003. Also, this is on your flash drive. We have slides from an EPA workshop that they did back in the early 90s. The NESHAP BB and FF FAQs, a TCEQ NESHAP FF flowchart, which can be helpful, but then again, take that with a grain of salt because, yes. Yeah, so be careful with how you use it. We have some ADIs on there, including the sour water ADI. EPA region guidance for the 90-day reports, for your quarterly reports, API settlement rulemaking, an AWMA paper, and the EPA B1 penalty policy. Just tell me. Okay, so you have a B1 regulatory dilemma for which you just can't find an answer. Your EHS manager asks you whether submitting an ADI for this issue is the correct next step. So what are the advantages of submitting an ADI? What are the disadvantages, and what are some other options? So what's one of the advantages of submitting an ADI? You might hear what you want to hear, but a disadvantage, I would be more nervous, would be you get an answer you don't want. And then everyone's mad at you. Yeah. Yes. So some advantages, US EPA allows to request facility-specific rule applicability determinations. There's a database online. If you go to this link, you can see the ADIs. But I don't think all of them are online, because a lot of people don't have that sour water one, which is on your...
I mean, there's a lot of ADIs that ended up going to the client who asked the question, but did not get actually published.
Right.
And we do actually have some of those on the
Yes. These may be used as a defense against erroneous violations or statements by regulators. But disadvantages, a lot of times people will submit an ADI, but they never hear back from EPA, or if they do, it's 10 years later and it's a moot point. And they might be risky because you might not get the answer that you want. So that is it for the actual presentation today.
Anyone have any questions from today? I know today was a very exercise intensive day. No? None? Okay, so we have our B1 Jeopardy. We are short again over here, so if you guys would like to pick someone from either team, red room or red room. Alright. Would you like to pick someone else, or you guys got it?
Volunteers.
Does anyone want to volunteer
Be
to come
on the
over?
list here.
There we go. That's all you had. All you had to say is winning team, because he's a winner. You're the worst. You're not supposed to say that for fun. I don't care. I need to betray us. Okay. So we're actually going to let this team go first this time, today. So, who would like to read it? Oh, I forgot. I never trust. Always verify. I never trust PowerPoint slides. To try to make it exciting. Yes, you guys are picking first today.
Be gone and be gone.
For 300 points? Hold on a second. There's something like right over here. Hold on a second. Lauren, there's something.
What? It's not right.
I need a screen like this. Oh, there it is. Okay, sorry. I have it now.
The frequency at which a report must be submitted summarizing any leaks or other problems that were observed during B1 inspection and monitoring.
We didn't go over that.
Huh?
I don't remember that slide. It's not fair.
What is quarterly?
I know. It's saying.
Yes, what is quarterly? Oh, wait.
Yeah,
That is.
quarterly, you just have to say you did it. Annually, you say your
You have to
problems.
report the finding and if it was fixed already, right? I was trying to do two things
Where do we just certify that you've done everything?
Right, sorry.
And then if you have any clear
I'm bouncing between
outages
computers
or-
here. Sorry, guys.
There you go.
All right. Please select the category.
Let's go with stripper and barely know her for 400.
Oh.
The monitoring frequency for breakthrough on carbon canisters.
No, it's, we call it mean time between failure, but I don't know what we call it in the slides.
Should I be one?
Oh, maybe.
Okay, I need an answer. Sorry.
What the design basis is for 20% of,
Your mean time between failure.
No. Would you guys like to steal? You think you know it? Of course you know it.
What is 20% of the design or daily?
Yes. Very good. Where am I? There. Daily or 20% of the design interval. All right. B West. No, you're B East. They're B West. Put it on my tab for 300. The three control options or standards for storage tanks include floating roofs, closed vent system to control devices, and this.
What is a conservation bid?
I need more information. No. You guys know?
You say no?
You don't have to steal. Do you want to steal? Okay. No, I need an answer on the steal now. I don't have to have the answer yet, though.
I know, I was like, wait a minute, I know they have something.
I guess we'll steal.
Okay, go ahead.
What is a fixed roof with a conservation bin?
That's what they said. I need more information. It's, yeah, you didn't get it.
Control with the paper pressure.
If the tank is managing less than 10% water. That's the part I needed.
What if it was less than 14,000 gallons? We didn't say that one.
Oh, I didn't ask for that one. Oh, I forgot to mention the one major rule of Jeopardy. I make the rules.
Let's go with aromatically evolved for 300.
The frequency at which sampling must occur to determine benzene concentration entering an enhanced biodegradation unit. Yes. Dun dun. Monthly. That's your compliance point into your EBU. The east.
No swimming in the waste stream for 300.
No swimming in the waste stream for 300. One method of determining waste quantities requires that you use the maximum annual quantity of waste generated over this period of time. Uh-oh.
What is 5 years?
Yes. I knew you weren't going to get it wrong 2 days in a row.
Said 3 yesterday.
Yeah, I got it wrong yesterday. All right, you guys. The West. What is it?
We're gonna go with BWON with BWON for 400.
For 400?
We're going for a new.
These are 3 typical operating parameters that are discussed in the definition of an EBU. Oh, you got the,
No, we can do this. We're good.
No, I don't remember. I remember barely half the acronyms he said.
Yeah, I don't know.
None of them?
Well, Pat.
One of them?
Is that legal, Brian? Is that legal?
Oh, no.
I don't know.
I have no.
Okay, all right, just make sure. Yeah.
I know 2 of the 3, but I don't know. What is the F to M ratio, the MLSS, and the detention time?
Yes.
Well, what is MLS? What is that?
Mixed liquor suspended solid.
Mixed liquids. Okay. I didn't know.
And FDM is food to microorganism ratio. So the food is your waste and the microorganisms are bugs. Yes, we did. On day 1, which was yesterday. It feels like 3 days ago, but it was just yesterday. All right. You guys.
Got a stripper I barely know her for 500.
All right. Everyone in the room. Okay. The B1 regulation allows for safety devices to be used on this type of waste management unit. Does that not seem right? Hey, Mary Claire. That's not right. And in the rule, does it talk about containers? We talked about that.
That works if they meet the vapor pressure and size.
Right. Yeah, that one. Close it.
I would say that. Or fix your tank if they meet those.
And container. We talked about containers that not being specifically mentioned in the rule. Unless you called it an organic container, right?
What are tanks? Wow. We gotta give you a certain type of tank?
Oh, man.
Give us one little bit more information on this.
Well, BWON defines a waste management unit as a container or tank, right?
Yeah.
Yeah, but I can't give it to you. I can't give it to you.
What is a fixed route?
Yes.
Well, I think it answers twice.
She said we have to tell her what type tank.
After 2 seconds, she said go.
Everyone's struggling today, so we're gonna get this. Come on, we're picking it up. So that's fixed roof tank, closed vent system, and containers. Because remember we talked about containers the other day too for scenarios. No, you only had to answer one. You only had to answer one. The containers. So remember we talked about containers the other day? How would a conservation event be allowed on a container? And we talked about scenarios as to where it would. Yes. Doesn't it feel like 3 days ago?
Yes. Today,
No. Today's only day 2. I'll be super kind to you guys on a question here.
Go with BWON for 500? Yeah, 500.
Enclosed combustion devices used to control B1 waste management units must either meet concentration limits, % reduction, or operate to meet these combustion standards. This is like probably one of the hardest ones. No, this one wasn't on there yesterday. This is probably one of the hardest ones. But some people may know it. Think about a combustion device, monitoring perimeters. I helped you guys out last time, so now I'm going to help them out a little bit.
What is the destruction efficiency?
No. Would you guys like to answer? No? You have a destruction efficiency, so % reduction, you see, it is already here. Or the other one, the standards, which is minimum residence time of half second and minimum temperature of 14. This is when you guys were all glazing over the control device standards Mary Claire went through yesterday, obviously. So, okay. No, they were there. Aw. For 300? The rule describes these 2 methods for determining benzene concentrations in waste streams. I need both of them.
Our sampling and process knowledge?
Yes, sampling and knowledge of the waste. Just put it on my tab for 500. These are the numerical control efficiency requirements for carbon canisters. You really know how to pick them, Laura. You guys got this. You got this.
She said it's 95 and 98, which is questionable.
Hey, you already took one of our
We just
teams.
repeated what you said.
I didn't hear what she said, I was asking. I thought she answered it, I didn't know.
Oh.
I didn't say what it is, so it wasn't.
She was talking to her. I took it as talking to the teammates rather than. Come on, guys. Need an answer.
There's two, there's one for VOC and there's one for benzene.
Yeah.
And they are?
To say,
I just need to pick which one of them is for benzene.
All right, I need an answer. I need an answer. I need an answer. No, talk to me. What's that? Yes, and you need to tell me which is for what.
Yeah.
Now,
What is 98% for benzene and 95% for VOC?
yes.
Coming for you.
Here we come to get you.
Whatever y'all think.
We'll stick with the strip.
Containers in which this is occurring are required to be equipped with a closed vent system and control device, or to a control device.
What is waste treatment?
Yes. What is treatment? You are correct.
Let's go with,
Got to make some strides.
yeah, we're gonna go with, for aromatically involved for 500. Do it.
Deep well injection and use of a RECRA permitted furnace are allowed methods of doing this to a BWON waste.
One is destruction.
I can't know. I mean,
You were really nice to them.
you give it to her? Can I give him this one?
No.
Destruction? Really?
Uh,
Oh, there we go. I mean, destruction is treatment, but you know.
Oh, now y'all are.
I gave you like 10 minutes to give me fixed roof in front of tanks, so. I'm just kidding. Treatment. And it was funny because that was their answer the last time, so it was. All right. You're gonna knock them back down in their place with a 500-point question?
Stick with the strip.
You're sticking with the stripper? Okay. The tap contribution for streams containing greater than 10 ppm sulfur or ammonia are managed in an enclosed sour water system may be counted at this location.
Oh,
He's ignoring you. And your answer is?
What is the outlet of the sour water?
Yes. Because the inlet of the sour stripper would be a huge stream.
and they barely know her.
she's gone now.
Let's do the last 500. No swimming for waste. 500.
Any bypass line from a closed vent system must be equipped with one of these items.
That's talking.
Man, they're cut down over there and they're winning. So, have pity on us. We just got a positive.
I will give me one of the options. Yes. Car seal. So flow indicator, car seal, or lock and key type configuration. They probably shouldn't put that there. Yeah, I should probably move that. Okay, which one?
Oh, yeah,
Let's do one of the columns.
although they're not necessarily easy.
That's true.
About, just put it on my tab for 200.
Just put it on my tab for 200. These are two numerical treatment standards in B1 listed in 348. Does everyone remember what 348 is? Treatment standards. Move over here. For a minute.
I was just here for that wastewater question.
Okay, need an answer.
Same two as before. What is 95% VOCs and 98% deputies?
Oh no. You're passing? Those are control devices. These are treatment standards. So if you were a stripper, so less than 10 ppm benzene or 99% removal.
I did it first. Uh-oh.
Oh, man.
Let's do, put it on my tab for 400.
Waste that is contained in this type of sewer system is not subject to the requirements of B1. What'd she say?
Sanitary.
A lot of sanitary systems just tie into your wastewater treatment plant with everything else. Okay, need an answer. You guys are standing between me and a poster session. Or maybe a bar, I don't know.
What is uncontrolled
No,
individual drain system by?
no.
You should assume this is a refinery or something.
Pass.
You're passing?
We pass them, but is it controlled?
No.
Okay, well, I'm glad we
I
passed.
think that counts as a guess.
No, we said we passed.
Segregated storm.
What is segregated storm sewer?
That's some Pacific Creek stuff, I think. We're supposed to believe it.
Okay,
Be gone with B1 for 100.
for
Oh, you want to go 200?
Let's go all out.
200 all out? These types of facilities are potentially applicable to the control and treatment standards under B1. What are our facilities?
All of them?
Yes, all of them.
Seriously?
Yes.
Got it.
3 of them?
You got this.
Till Thursday afternoon.
Seriously, all 4 of them?
Yeah, seriously. 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 That's Charles Barkley. Okay, gonna need an answer.
What is it, chemical plant, refinery, DA?
And a terminal contiguous to
Come on, that's close. There, we still negotiating.
All right. You got it?
Okay, yeah, we're gonna seal. So what is a refinery, petrochem plant, waste treatment facility, and then what was Coke.
Okay. I told you 3 of them. What was the 4th?
She got the first Coke byproduct.
Coke.
Coke, a byproduct. But you said petrochemical plant. Doesn't necessarily have to be a petrochemical plant, just a chemical plant. Any chemical plant that might contain benzene. All right, but it is your turn to choose.
I picked some good ones this time. Let's go with aromatically involved for 400.
1800 ppm.
Should I question this?
Yeah.
The slide also says 14 to 1600 ppm.
That's
That's not really.
Yeah, but I said it specifically.
Gosh, Lee. You want some favoritism.
So what is the maximum concentration of benzene in the water?
Yes, what is solubility benzene in water?
No swimming in the waste stream for 200.
The frequency of inspection required for car seals on closed vent system bypass lines.
This is for 400?
400? Oh, you said 200?
Yes.
We'll take it.
You don't have to. I can put it back. But everyone has to close their eyes and look the other way.
What is monthly?
Yes. I could have gone back. You didn't have to keep it.
Okay, we'll take the no swimming noise
For
for 200.
200? The benzene quantity in waste streams containing less than 10 ppm benzene and entering this type of unit are not required to be counted to the uncontrolled benzene quantity under the 6 megagram compliance option.
What is the EBU?
Yes. $200? Owners and operators must demonstrate that each control device achieves the applicable control requirements by using one of these methods. Yes. You want to say the other one? Ooh, I almost did that again. engineering calculations. Yeah. All right.
Put it on my tab for 100.
If a facilities tab is greater than this value, the facility is subject to control and treatment standards.
What is,
Ooh, I'm still figuring, brainstorming. What is that?
Yes.
Big on with big one.
Waste with this characteristic are required to be controlled under the 6 megagram compliance option.
What is organic waste less than 10%?
Yes.
No swimming in the waste stream.
The location where a stream exits the process unit component or storage tank prior to handling or treatment in an operation that is not integral, it is not an integral part of the production process. Yeah, this is just sad. I'm feeling really bad about myself right now.
Where does the pointer generate?
Yes! Oh my goodness. You guess? Okay. Waste with this characteristic may be exempted from control and not counted to the 2 megagram limit under the 2 megagram compliance option.
What is waste less than 10 ppm?
Yes. Awesome, guys. Congratulations. We do have end-of-day evaluations for today, and then we can get out of here.